Right, now we will start with another chapter of derivative, another subpart of derivative, which is very similar to what I just taught you, which is very similar to your composite function. We still are on derivatives. We are going to see composite functions of exponential and logarithmic function. So this is a kind of composite function part 2. Now let's start with the sum. We have already seen how composite functions are. Let us see a sum based on this. We just leave this here for the timing so that we know what we are doing. Y is equal to e raised to x square minus 2x plus 10. Right? Simple method. First, differentiate with respect to x. That means you multiply both sides by d by dx. So d by dx of y is d by dx of e raised to x square minus 2x plus 10. I'm going to apply the composite function or the chain rule, whatever you may call it. This is e raised to, instead of x there is a polynomial here, that's how I identify that it is composite function. So you will use the rule e raised to u. Now d by dx of e raised to u is e raised to u d by dx of u. So this is going to be e raised to x square minus 2x plus 10 into d by dx of x square is 2x minus d by dx of 2x is 2. So your final answer will be twice x minus 1. I'm taking 2 common between these two terms. E raised to x square minus 2x plus 10. Let's see another sum, people. Y is equal to 5 times e raised to x into sin x. Right? See how do we do this sum? Same method. Differentiate with respect to x. Multiply both sides by d by dx is d by dx of 5 e raised to x sin x. Now we know that d by dx of a raised to x is a raised to x log a. I'm going to use the composite function wherein I'm going to use d by dx of a raised to u. So d by dx of a raised to u, this whole term I'm assuming as u, because instead of x there's a composite function here, right? So d by dx of a raised to u is a raised to u log a d by dx of u. What is u? The indice is u here. So e raised to x sin x. Now this is going to be 5 e raised to x sin x log 5. Here, since there is multiplication between two terms, this is going to be uv formula. So this is v derivative of u plus u derivative of v. Multiplication formula I'm using. So this is 5 raised to e raised to x sin x log 5. This is sin x. D by dx of e raised to x is e raised to x plus e raised to x. D by dx of sin x is cos x. So I could take e raised to x common here. 5 e raised to x sin x. You could take e raised to x common in this. So you will have sin x plus cos x into log 5. Right? That will be your answer for this sum. Let's move on to another sum, guys. Y is equal to log of log x. Right? Let's see how do we do this sum. Differentiate with respect to x. So d by dx of y is d by dx of log x. Assume this log x to be u. If I assume this log x to be u, then it becomes dy dx of log u. Dy dx of log u is 1 upon u dy dx of u. Now apply straightforward formula 1 upon log x as it is. Dy dx of log x is 1 upon x, hence your answer is going to be 1 upon x log x. Simple, straightforward. Let's see another example. Y is equal to 2 raised to x log x the whole raised to 4. Right? Same thing. Differentiate with respect to x. Now, since there is multiplication term here, first let's write the dy dx. Dy dx of 2 raised to x log x the whole raised to 4. Now, since there is multiplication here, you will be using the uv formula or the multiplication formula. Assume the first term to be u, the second term to be v. So dy dx of uv is v derivative of u plus u derivative of v. Let's see this. This is log x the whole raised to 4. Dy dx of 2 raised to x is nothing but 2 raised to x log 2. Dy dx of a raised to x is a raised to x log a plus 2 raised to x. Here again you use composite formula. This is going to be u raised to n. So n u n minus 1 dy dx of u. So this is going to be 2 raised to x log x the whole raised to 4 log 2 plus 2 raised to x 4 log x the whole cube. Dy dx of log x is 1 upon x. Now let us see what we can take common here. You could take 2 raised to x common. You could take log x the whole cube common. In which case you will have log 2 remaining from here plus 4. I have taken log 2, log 2, that means log 2 into log x will remain common from here. Because this is log x raised to 4, you have taken only cube common. Plus 2 raised to x gone, 4 remains from here upon x. So that will be your answer. Fine. Let's move on to the next sum, people. Y is equal to log of cos x to the base a. Right? First thing that we do is apply the change of base rule. Differentiate with respect to x. D by dx of y is d by dx. If I apply the change of base rule, this will become log of cos x upon log a. This is called as the change of base rule of log. I'll write the rule here. If log m to the base n, by change of base rule is nothing but log m upon log n. So this is the rule that I have applied here. That's my change of base rule. Now, since 1 upon log a is constant, it will come outside the derivative. D by dx of log u is 1 upon u d by dx of u. Right? So this will be 1 upon log a 1 upon cos x. D by dx of cos x is minus sin x. Now sin upon cos is tan, so this is minus tan x upon log a. That will be your answer. Let's see one more sum, people. Y is equal to log a to the base cos x. Same thing that we did in the previous sum. You have to apply change of base rule. Differentiate with respect to x. D by dx of y is d by dx of log a to the base cos x. Right? Now, if I apply change of base rule, this will become d by dx of log a upon log cos x. log a is constant, comes outside the derivative sign, d by dx. I'm bringing this whole thing up in the numerator. Since I'm bringing this in the numerator, the indice will become negative, so this will become log cos x the whole raised to minus 1, log a as it is. D by dx of u raised to n is n u n minus 1 d by dx of u log cos x, right? Let's see this. This is going to become minus log a, negative 2 taken in the denominator is log cos x the whole square. Now d by dx of log u is 1 upon u d by dx of u. Now d by dx of cos x is minus sin x. This is minus log a upon log cos x the whole square. D by dx of cos x is minus sin x. Okay, so this is minus sin x upon cos x. Minus into minus is plus. So your final answer is going to be log a into sin upon cos is tan x upon log cos x the whole square. That will be your answer. Fine, do you understand this? Now let's move on to the next one. Now let's move on to slightly more interesting topic. Y is equal to log x plus root of x square plus a square upon minus x plus root of x square plus a square. Right? Now let's see the sum. Since there is a square root sign here, I need to get rid of the square root sign, for which I could rationalize. How? Let's see this. Log x, this can be written as root of x square plus a square plus x upon root of x square plus a square minus x. I have just rearranged the terms. Now I'm going to rationalize the denominator. To rationalize the denominator, I'm going to multiply by root of x square plus a square plus x upon root of x square plus a square plus x. I rearranged the terms and I have rationalized the denominator. Now let's move on ahead. Log x, this is root of x square plus a square plus x into root of x square plus a square plus x, which is nothing but root of x square plus a square plus x the whole square. In the denominator, this is a minus b, a plus b, which is going to be a square minus b square plus x square minus x square gets cancelled. This can be written as y is equal to log root of x square plus a square plus x the whole square upon a square. Log a upon b is nothing but log a minus log b. So this is going to be log root of x square plus a square plus x the whole square minus log of a square. Whatever is the term in the indice comes before the log. So this is 2 log root of x square plus a square plus x minus 2 log a. Same thing. Whatever was the number in the indice, I brought it before log. Now differentiate with respect to x. If I differentiate with respect to x, I'll get d by dx of y is d by dx of 2 log root of x square plus a square plus x minus 2 log a. 2 is a constant, comes out. D by dx of log u. D by dx of log u is 1 upon u x square plus a square plus x. 1 upon u d by dx of u root of x square plus a square plus x minus 2 as it is. D by dx of constant is 0, right? So this 0 remains there. Now this can be written as 2 upon root of x square plus a square plus x. Now let's try solving this, people. Now when I open the bracket, this will be d by dx of root u. D by dx of root u is 1 upon 2 root u d by dx of u. So d by dx of x square plus a square plus d by dx of x is going to give you 1. 2 into 0, 0, anything multiplied by 0 is 0, so you need not write that. This is going to be 2 upon square root of x square plus a square plus x. Now this is going to be 2 square root of x square plus a square. D by dx of x square can be written as 2x. D by dx of a square is 0, I need not write that, plus 1. 2 and 2 gets cancelled. Now this can be written as 2 upon, I can rearrange this term as x plus root of x square plus a square. LCM x plus root of x square plus a square upon root of x square plus a square. X plus root of x square plus a square in the numerator and denominator gets cancelled. Your answer is 2 upon root of x square plus a square. Right? That will be the answer for the sum. Let's move on to the next sum, guys. Y is equal to log e raised to mx plus e raised to minus mx. Now this is the sum. Let's see how do we do this sum. Differentiate straight away with respect to x. D by dx of y is d by dx of log e raised to mx plus e raised to minus mx. Now this is going to be log u. Log u is 1 upon u d by dx of u e raised to mx plus e raised to minus mx. Now this is 1 upon e raised to mx plus negative indices can be converted into positive as 1 upon e raised to mx. Let's solve this. D by dx of e raised to u. D by dx of e raised to u is nothing but e raised to u d by dx of u. Similarly, again d by dx of e raised to u is e raised to u d by dx of u. Right? Now let's take LCM here. E raised to mx into e raised to mx is going to give you e raised to mx the whole square plus 1. The common denominator can be written in the numerator. Let's see this. E raised to mx into d by dx of mx is going to give you m plus e raised to minus mx. D by dx of minus mx is going to give you minus m. Right? Now here I could take, this is e raised to mx upon a raised to m raised to n is a raised to mn, e raised to 2mx plus 1. I could take m common here, so I'm bringing the m common outside. That leaves me with e raised to mx minus, convert the negative indice to positive, 1 upon e raised to mx, right? Again you do LCM, m e raised to mx upon e raised to 2mx plus 1, e raised to mx into the LCM, e raised to mx the whole square minus 1 upon e raised to mx. E raised to mx in the numerator and denominator cancel each other. So your answer will be m times e raised to 2mx minus 1 upon e raised to 2mx plus 1. That's your final answer. Right? Let's move on to the next sum, guys. Y is equal to log e raised to x plus e raised to minus x upon e raised to x minus e raised to minus x. Right? First thing we need to do is convert the negative indice to positive. How do I do that? This can be written as y is equal to log e raised to x plus 1 upon e raised to x, e raised to x minus 1 upon e raised to x. What am I doing here? I am converting the negative indice to positive. Okay. Now this can be written as y is equal to log e raised to x into e raised to x is e raised to x the whole square plus 1 upon e raised to x. I've done LCM. Same thing in the denominator, e raised to x the whole square minus 1 upon e raised to x. E raised to x in the denominator gets cancelled, so I'll get y is equal to log e raised to 2x plus 1 upon e raised to 2x minus 1. Right? Log a upon b is nothing but log a minus log b, so e raised to 2x plus 1 minus log e raised to 2x minus 1. Log a upon b is nothing but log a minus log b. Now differentiate with respect to x. So you will get dy dx of y is dy dx of log e raised to 2x plus 1 minus log e raised to 2x minus 1. Right? Now this could be written as log u. Dy dx of log u can be written as 1 upon u d by dx of u. Same way, dy dx of log u is 1 upon u d by dx of u. Right? Let's see this. E raised to 2x plus 1 as it is. Dy dx of e raised to u is e raised to u d by dx of u, right, minus e raised to 2x minus 1, d by dx of e raised to u is e raised to u d by dx of u. Right? Now this can be written as e raised to 2x can be taken common. Now d by dx of 2x is going to give you 2 upon e raised to 2x plus 1 minus, I have already taken e raised to 2x common out there. D by dx of 2x is going to be 2 e raised to 2x minus 1. In the numerator I could take 2 common, so this is 2 e raised to 2x. Inside you will have 1 upon e raised to 2x plus 1 minus 1 upon e raised to 2x minus 1. You could do LCM here. 2 e raised to 2x, I am doing LCM now. E raised to 2x minus 1 minus e raised to 2x minus 1, because this minus into plus is going to give you minus. upon e raised to 2x plus 1 e raised to 2x minus 1 plus e raised to 2x minus e raised to 2x gets cancelled. Minus 1 gives you minus 2, multiplied here will give you minus 4 e raised to 2x upon e raised to 2x plus 1 e raised to 2x minus 1. That will be your answer. Let's see another sum, people. Y is equal to log e raised to x plus x minus 2 upon x plus 3 raised to 3 by 4. Right? Let's see how do we do this sum. Simple, straightforward. In log, multiplication changes to addition, division changes to subtraction. Use a simple formula and you will get this. This can be written as log e raised to x, multiplication changes to addition, log x minus 2 raised to 3 by 4, division changes to subtraction, log x plus 3 raised to 3 by 4. Whatever is the number in the indice comes before log. So this will be x log e plus 3 upon 4 log x minus 2 minus 3 upon 4 log x plus 3. We know the value of log e by heart. Log e is 1, so this will be x plus 3 upon 4 log x minus 2 minus 3 upon 4 log x plus 3. Right? Now, differentiate with respect to x. If I differentiate with respect to x, I'll get d by dx of y is d by dx of x plus 3 upon 4 log x minus 2 minus 3 upon 4 log x plus 3. Right? Now d by dx of x is 1 plus 3 upon 4 as it is. D by dx of log u is 1 upon u d by dx of u minus 3 upon 4. D by dx of log u is 1 upon u d by dx of u. Right? Now this can be written as 1 plus 3 upon 4x minus 2. D by dx of x is 1, 2 is 0, minus 3 upon 4 x plus 3. D by dx of x is 1, d by dx of 3 is 0. Now between the second and the third term, I could take 3 upon 4 common, 3 upon 4 common. That leaves me with 1 upon x minus 2 minus 1 upon x plus 3. 1 plus 3 upon 4. This is x plus 3 minus x minus 2 upon x minus 2 x plus 3. Right? Now simplify this further. When I open the bracket, this x and this x will get cancelled. 3 minus into minus plus 2. 3 plus 2 is 5. 5 3s are 15. So answer is 15 upon 4 into 1 upon x minus 2 x plus 3. That will be the answer. Right? Let's see another sum, guys. Y is equal to log of x to the base 10 to the base 10. Right? Now this can be written as differentiate with respect to x So you can say d by dx of y is d by dx of log x to the base 10, and the 10 which is outside, I'm going to use the change of base rule for that. So log 10. Now this can be written as 1 upon log 10 as it is. Log u, d by dx of log u is 1 upon u d by dx of u, right? So this is going to be equal to 1 upon log 10 into 1 upon, apply change of base rule here. So this will be log x upon log 10. Now this can be written as d by dx of log x upon log 10. I'm applying the change of base rule here again. Now log 10 gets cancelled. This is 1 upon log x. 1 upon log 10 comes out constant. D by dx of log x is 1 upon x. That will be your answer. Right? Let's see another sum, last sum to finish off this chapter. Y is equal to log x to the base 10 plus log 10 to the base x plus log x to the base x. Right? Let's see how do we do this sum. Differentiate with respect to x. D by dx of y is d by dx. Apply change of base rule. Log x upon log 10 plus log 10 upon log x plus log x upon log x. Log x gets cancelled, so you will have 1 here. Let's solve this. 1 upon log 10 constant, d by dx of log x, 1 upon x plus log 10 constant d by dx. The log x which is in the denominator, I can bring it in the numerator as log x to the base minus, to the index minus 1 plus d by dx of 1 constant. D by dx of constant is 0. So this is going to be 1 upon x log 10 plus log 10 d by dx of u raised to n, composite formula. D by dx of u raised to n is n u n minus 1 d by dx of u, right? So this can be written as 1 upon x log 10 plus into minus minus log 10. This negative index, when it goes in the denominator, will become positive. Log x the whole square. D by dx of log x is 1 upon x. So your final answer will be, I can take 1 upon x common. 1 upon log 10 minus log 10 upon log x the whole square. That finishes the chapter, and that finishes this sum. Let's stop here. Thank you very much.